Okay, we're going to do lesson 2.8, which is on solving equations in one variable, and specifically solving rational equations, where we have one polynomial over another polynomial and they have no common factors. So we want to solve rational equations by first finding the least common denominator of all the terms in the equation, and then we're going to multiply both sides of the equation by the least common denominator. And that's so when we first see the problem, we're going to have a bunch of fractions, and this is going to help us get rid of those fractions and give us a simpler problem to work. The downside of multiplying both sides of the equation by the least common denominator is that sometimes it will give us solutions that don't actually work for the original equation, and those are called extraneous solutions or extraneous values. And that just really means extra solutions that don't work for the original problem. Alright, so for our first problem, we have one denominator and it's x. We want to think about this problem as if we have a denominator under all of the terms, and so we would have x over 1 plus 3 over x equals 4 over 1. So our common denominator here, we're going to look at the denominators that we have. We have 1 and x, so the greatest or the least common denominator in this case would be x. We would take one of each and we could say, well, 1 is a denominator that I see, x is another denominator that I see, and then their product itself is x. So I want to multiply both sides of my equation by that denominator. And when I do that, I'm actually distributing both of these terms. So I'm not just going to multiply one of the terms by x, I'm going to multiply both of those by x, and I end up with x times x is x squared plus 3x over x equals 4 times x. I went ahead and put the x in the numerator just to show you what happens, the reason why we're multiplying by x on both sides and eliminating the numerator, or eliminating the fractions, is by eliminating the numerator and denominator here. So ultimately we're getting rid of all of our denominators and we have left x squared plus 3 equals 4x. And I'm ready to solve my equation in a little bit simpler manner. Bring everything over to one side of the equation and set everything equal to 0. X squared minus 4x plus 3. So I went ahead and put all my terms in descending order. And then if it's possible, I'm going to try to factor it. If not, you can always use the quadratic formula to help you get your solutions. In this case, I can factor, and you can always use the quadratic formula if you want to. That's fine. I just find it easier to factor here. So I'm going to put an x, and then to get a product of 3 and a sum of negative 4, I'll have a negative 3 and a negative 1 equals 0. And then set each of those factors equal to 0. And then I solve, so here x would equal 3 and x would equal 1. Now again, we said at the beginning that when I get some solutions, after I've multiplied by both sides by a common denominator, I can have ones that really don't work for the original problem. So you're going to have to take that extra step and check each one of your solutions to make sure that it does work. So I'm going to check 3 first and just substitute it into my original equation. X plus 3 over x. Back up here, I don't want to put x, I actually want to put the 3 in there, because that's what my solution is, or my perceived solution is. And then I get 3 plus 1 does equal 4, so that checks out. And so x plus 3 is a solution of my original equation. Then I want to do the same thing with 1. So I would have 1 plus 3 over 1 equals 4, which is 1 plus 3 equals 4, which is a true statement. So x equals 1 is also a solution of my original equation, and I would state it as my solutions are 1 and 3. All right, I want to take a look at the next problem. We have a little bit more complex problem, but we still only have one denominator. And you'll notice in the last one, we only really had one denominator, and that denominator x also became our least common denominator. Same thing's going to happen here. We only have one denominator, and so x minus 4 is going to become our least common denominator. And I want to multiply both sides of the equation by x minus 4. When I do that, each term is going to be, eventually is going to be multiplied by x minus 4. So I'm going to go ahead and do that. And so any denominator that I have, well, it should cancel if I've done it correctly. I have x minus 4 times x plus, I still have my 1. And 0 times x minus 4 is simply 0. Go ahead and multiply that out. X squared minus 4x plus 1 equals 0. In this case, it does, it's not factorable, so I'm going to use the quadratic formula. This is going to be a, b, and c. Remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Just to kind of speed this up a little bit, after I work through the quadratic formula, I find that x potentially is equal to 2 plus or minus the square root of 3. So I'm going to have to take that and substitute that into my original equation. Keep in mind there, that's two separate solutions. And so I would substitute 2 square root, you can't do approximation, you actually have to put 2 plus square root of 3 into the original problem. I'm just going to erase this so that we can see the original problem a little bit better. And I'm going to substitute that 2 plus square root of 3, and then you again do it with 2 minus square root of 3. So that's x plus 1 over 2 plus square root of 3 minus 4 equals 0. Its denominator reduces to negative 2 plus square root of 3. We're still going to have to, we do have basically a whole number plus a fraction, so we're going to have to find a common denominator just like we did with the x minus 4. And our common denominator here is then that negative 2 plus square root of 3, and we'll multiply by that binomial. And so that negative 2 plus square root of 3 would then be my common denominator. When I multiply through using FOIL method, I'm going to get negative 4. My middle terms will cancel, plus 3, and then I get to add my 1 here. So plus 1 over negative 2 plus square root of 3. Which is negative 1 plus 1, which is 0. So that 2 plus square root of 3 is a solution. It actually works for the original problem. And again, just to kind of speed things up, 2 minus square root of 3 also works in the original problem. So that's also going to be a solution. So both of those work. and I would put them in solution set brackets and say 2 plus or minus the square root of 3. All right, so we have a pretty large problem here, for example 3, where we have 3 separate denominators. You should notice that x minus 1 is completely factored, x minus 3 is completely factored, and then we've got x squared minus 4x plus 3, which is factorable. So I'm not going to leave it as is, I'm going to factor it. Its factors will be x and minus 3 and minus 1. So you can see that it's made up of the same factors as our other 2 terms in the problem. Since these 2 terms also have the same factors as my larger polynomial here, I'm going to use x minus 3 and x plus 1 as my least common denominator. And so I'm going to multiply all the terms by that factor. So this one will be multiplied by x minus 1 times x minus 3. This one is multiplied x minus 1 times x minus 3. And then this one is x times x minus 1 over x minus 3. Always going in the numerator, by the way, so that this numerator and this denominator will reduce completely. This denominator and this numerator will reduce completely, and this numerator and this denominator will reduce completely. And I can multiply it out. I have an x minus 3 times 2x. And plus I have a 1 times x minus 1 equals, since my numerator and denominator canceled here and here, I have a 2 left. So I'm going to multiply this out, so simplify a little bit. 2x squared minus 6x plus x minus 1 equals 2. That's 2x squared minus 5x minus 1 equals 2. I want to bring everything over to the left side of the equation, so I'm going to subtract 2 from both sides. That gives me 2x squared minus 5x minus 3 equals 0. And when I can factor this one gives me factors of 2x plus 1 and x minus 3. And so when I go and solve, I get 2x plus 1 equals 0, x minus 3 equals 0, (2x) equals negative 1, and so x equals negative 1/2. And here, if I add 3, I get x equals 3. Again, these are possible solutions, and you have to go through and check them. So you need to try negative 1/2 out with your equation to see if that one works. And I'll just give you a little hint. That one's going to work out and make a true statement. So negative 1/2 is a solution. Let's look at 3 as whether it's a solution or not, and see what happens. So for 3, I'm going to put 3 in for x in the original equation. That's 2 times 3 Okay, so that's what it looks like. And the first term is going to be, that's going to be 6 over 2, or 3. But when we get to this next term, this is going to be 1 over 0, which of course is undefined. And for this one, this is going to be 2 over That's 9 minus 12 is negative 3, and negative 3 plus 3 is 0.